I'm Mark Cavanaugh for Cavi Coaches, and today we're going to look at a pretty complicated problem on kinematics, and I'm going to coach you up on how to troubleshoot when you get stuck. Got another popular question here where we've got a track situation with Usain Bolt, who set the world record in both the 100 and 200 back in 2008 Olympics. So we're going to look at this problem, and we're going to take an approach from using the kinematic equations first. So again, we want to thank Rice University and OpenStax for providing a free copy of a college level textbook for AP Physics in high school. So we can see here that we're looking for the maximum speed and the acceleration of Usain Bolt when he began the race and accelerated for the first 3 seconds of the race. We know that his initial velocity is 0. Now the problem is I have way too many unknowns in my kinematics, so I can't use my kinematic equations. So what I'm going to do is I'm going to create a velocity time graph. And I know that Usain Bolt sped up for the first increment of time and then ran at a constant speed for the remainder of the race. So I can see here that this is my first time that I have. That's the time where he was accelerating. So I'm going to call that T1. And then he ran at a constant speed for the remainder of the race. We're going to call this time TF for his final time. And we know that the final time minus the initial time is going to be the time that we have in between. So TF minus T1 is going to give us a time of T2, which would be this distance, this time measurement between T1 and TF. So now how are we going to use our velocity time graph to find the final velocity? Well, we have to remember that the slope of a velocity time graph is the acceleration, and the area underneath the graph is the displacement. And we can see from the race that Usain Bolt ran 100 meters. So we're going to go ahead and shade in this area to represent the total distance of the race that he ran. And we're going to write an equation in terms of just finding areas. So the area is going to be the area of a triangle plus the area of a rectangle. And length times width for a rectangle, but because the length is the same as the height, I'm going to use h for the length, just so I know it's the same variable. So now we're going to look at what this means in terms of physics. So the area represents the displacement. So we're going to write delta x. 1/2 the height times the base. Well, the height is the final velocity and the base is T1. So 1/2 of T1 times Vx. And then the same for our rectangle is height times width. So Vx times T2. And T2, remember, is just the base of that rectangle. So now we're set up to do some algebra and find the value of Vx. So we can first factor out a Vx, which leaves us with this equation, and then divide both sides by what's in parentheses to get a final equation for Vx. Now remember, we want to solve equations for variables first, because if this is an AP exam style question, you're going to have symbols instead of numbers for these, and it would ask you to write an expression for Vx in terms of x, T1, and T2. So this would be our expression. So now we're ready to plug some numbers in, and we can find our final velocity. And we could also use our final velocity then and use that on our velocity time graph to find the slope, to find the value of the acceleration. And that would be finding the slope from 0 to 3 seconds. So now if we look at part B is telling us that he ran a 200 meter, assuming the same conditions that we had to begin with. So he accelerated for T1 of 3 seconds. T2 is going to be 16.3 seconds. So another reason that we want to solve in terms of variables is because this just made part B much simpler, so we don't have to repeat the same process again. So we're ready to solve for both parts A and part B in terms of final velocity. Remember, for part A to find the acceleration, you can find the slope of the line once you find the value of Vx. So here's how you can use your kinematic equations along with a velocity time graph to to help you solve a very complicated problem. So once you write down all of your variables, don't get frustrated that you can't use the kinematic equations. So you just want to go and move on to the next step. Look at your velocity time graph and what do we know about the velocity time graph. So I hope this process was helpful. I hope you have a great day and an even better tomorrow. If you found this video helpful, don't forget to click the like button down below and subscribe to my channel, Cavi Coaches, and follow me on Instagram and Twitter @CaviCoaches.